We previously looked at the journey that water takes on its way to your homes. Now, if we zoom in a little bit, we typically are talking about the movement of water as a river. So this here represents a river. And we know that rivers typically then on their way to the ocean, they make collections called lakes. And lakes usually have at least one river flowing into them, and then they'll continue, they'll have a river flowing out of them. And again, they're still making their way to the sea. A little bit further downland, they'll make maybe another lake and so on, and they'll make a series of lakes. And this continues all the way to the ocean. Now, when we talk about this lake here, we'll say Lake A, we usually talk about the river uh, up here on this end before the lake. We talk about this as the upstream river upstream, and then we talk about the river below A, and we talk about this as the downstream section or the downstream river. So we say that we have upstream and downstream of each lake. Now, if we're talking about Lake B, well then, now this is the upstream and so on. This is upstream and this is downstream, right? This is downstream. Okay. Now remember that we want water. We usually make our settlements, so our houses and our buildings, we usually make them pretty close to rivers or lakes. And the reason why we want to do this is so that we can use that water. We can take that water from the lake. So say this here is a house, represent the house. We want to take that water and bring it into our home. So we can use the water. However, if we do something like what you've seen here, take the water straight from the lake and bring it into your house, there's a problem with this. This is not a good idea. The reason why this is not a good idea is because this water currently would not be safe to drink. We need the water to be safe to drink. We call this water potable water. We saw that in a previous lesson. Potable water is water that's safe to drink. This water currently is not potable. It's not potable right now. And the reason is essentially it hasn't been cleaned, right? There could be all kinds of stuff that happens up here in the upstream. So an animal could die and fall into it, or there's loads of clay and sediment from the water moving down through fields and bringing mud with it. And maybe animals are basically defecating, pooing into the lake, weeing into the lake, and so on. And just at the moment, this water, we can't guarantee that that water is potable, and we can't really accept that situation on our water supply. Just not possible. So we don't need our water to be not potable. We need to make sure that we don't do this process here. So this here, where I'm at, we don't want to do this here. So what do we do instead? What we do instead typically is we set up something called a water treatment plant. A water treatment plant, which essentially will take water from rivers, water supplied from rivers and water supplied from lakes, and then is going to treat it to make it potable before delivering it to homes. Okay, so this water is going to be potable. This water was not potable. That's the difference, right? Okay. So what we want to focus on is what are the processes that have to happen in the water treatment plant to make it potable, to make it safe to drink. That's what this lesson is about. It's about the water treatment process. And there are a number of different stages which we're going to go through now. So we're zooming in on the water treatment plant. What happens? Well, a water treatment plant typically takes a water supply. And what it'll do with that water supply is the first stage it's going to do is it's going to pass it through a number of screens or like crisscross kind of metal grids. And what this is going to do is any big objects, any large objects, so plastic bottles, or I've even seen, I remember being in the town I used to live in, you'd sometimes see shopping trolleys and old bikes thrown into the lake and into a river, and you'd see them flowing down the river. So big objects, they're essentially going to get stuck and they're going to pile up here at the screen and they won't be able to pass through, and only water gets through. So this removes large objects, right? So removing large objects or removing large, what we would call debris, is the first stage of water treatment, number one. It's called the screening process. It's using screens. This is a screen, a mesh screen. It's using a mesh screen to remove large objects. The water then is passed through into a big tank. So this here is a really large tank. And what happens is the water flows in at the bottom. Flows in, and of course then what happens is it fills up the tank, right? So it fills up until eventually it's up at the top. Now, sorry, I'm trying to roll back. Yeah, okay. So eventually it fills in, it goes all the way to the top, as you can see here. It fills up this tank. And once it's filled up this tank, then what happens is it's allowed to sit there. It's allowed there to sit there for maybe 2 to 3 days. And what happens is any heavy lumps of clay or mud or any other kind of debris that's here, this was able to pass through the screen, right? It's not that big, but any kind of lumps, bigger lumps in here, like this. Now, there will be tiny little specks as well, but the bigger lumps are all going to settle to the bottom. They're all going to settle to the bottom like this. The little ones won't, but the big ones will all settle to the bottom, and they'll form like a kind of a mess of basically mud, essentially, that we call sediment. The sediment will all settle to the bottom, and then what we can do is, using a pipe near the top of the tank, we can flow away the fresh water. Why do we do it from the top? Well, if you think about it, why would we not do it from the bottom? Why would we, if we took a pipe from the bottom and we took the water out, what's going to happen here is as the water is kind of moving down and it's going to unsettle the sediment's all going to kind of get agitated back up and mix with the water, and the sediment's going to go out this pipe as well. So we don't want that. We want to take it only from the clean water from the top of the tank. That'll avoid any of the sediment being in the water now. So essentially, we've lost the biggest particles of mud and dirt that are in the water. They've all sedimented or settled. So that goes with the first process. Screening and sedimentation are the first 2 processes. So first of all, water's passed through the screens to remove the biggest stuff. Then it sits in settlement tanks for a few days. This is called a settlement tank, by the way, settlement tank, because it allows the sediment to settle. Settlement tank. So big tanks where the sediment settles and the water is drawn away. Right. So there is the first stage of the water treatment process. Now we're not there yet. It's still not potable, still not ready to drink. So what happens now? Well, now we move into the next stage of water treatment, which is going to involve another tank. So the water is going to flow into this tank, right? So that water flows from there into here, right? Now, the thing about it is, though, we still have these smaller pieces of sediment floating in the water. These are the ones that weren't able to sink in the big settlement tank. First of all, mainly because they're too light. They're not heavy enough to sink. So these are still sitting suspended in the water. So these need a little bit of help in order to sink. What we want to do is we want to get them to clump together into bigger lumps so that they're heavier and that they sink down. So we want them to clump. Or anyone who does ag science will recognize this word. We want them to flocculate. So what we do is we add something called a flocculating agent. A flocculating agent. This is just a chemical. This is a chemical. And that chemical is usually a substance called alum. A-L-U-M. That's the name of the chemical. We add this alum in, this flocculating agent, we add it in. And what that causes the particles to do is it causes them to become attracted to each other. So they become attracted to each other so that they form one larger lump, right? So they stick together and they form a larger lump like that. So that's a combination of maybe 200 particles all clumping together. And now what's happened is that if we leave that to settle now, that particle is heavy enough to settle, kind of like how it did in the first tank, right? So essentially what we're doing here is we're causing all the particles to clump together. Clump or flocculate is a better word here. Clump together, and then they form a big enough particle so that they'll settle. All right, so what happens in this stage is that the particles clump or flocculate, Plump is an okay word, I guess. Plump or flocculate, and then they settle. So this stage, second stage, is known as the flocculation stage. Flocculation. So flocculation, alum is the chemical, so we'll put that in. Flocculation, alum. Alum is added. That causes the particles to clump together. They sink, then they settle. Again, still not ready to drink though, because there will still be some remaining sediment in there. And as much as you're trying to get this stuff to settle, there's still going to be other things in there that we need to remove, the tiniest sediment, right? So on to the next stage then. We're going to take that water that's just been flocculated. We're going to take that water and we're going to put it into or in through a giant filtration tank. Okay, so how does this work? Well, what you have here is essentially you have a big, massive kind of a basin, right, with a pipe out the bottom. And it works kind of like a filter, like what we've seen in chemistry before, right? But this filter isn't made of paper. It's not a paper filter like what we use in chemistry. Instead, it's made of a number of layers of material. So the bottom layer is that you fill it with down here, this layer here, this layer is sand. Sand is a very fine particle. So if you tried to pass water through this, it would remove the tiniest of particles, and then the water would come out much cleaner on the other side. So this is essentially cleaner water, water without sediment, right? And to be honest with you, that filter would probably work all by itself, right? But the only thing is that the sand would essentially would remove all particles, small and big, whatever's left. It would remove the tiniest of particles. And what would happen here is the sand would get clogged up very quickly because the biggest particles would sit on the top and they'd kind of block all the little pathways through the sand. So to stop that happening, scientists, they use other layers as well. They use layers of bigger stuff. So on top of the sand, they put gravel. So they put some layers of gravel. Okay, so the gravel obviously has bigger gaps in between than the sand. It's still pretty tight together. All the gravel particles are packed pretty tightly together, but they're not packed as tightly as the sand particles, right? So the gaps in between are going to be a little bit bigger, which means that the gravel layer here is going to remove some of the bigger particles, and then the smaller ones can be removed by the sand below. Sorry, it's taken a lot longer to draw than I wanted it to, but yeah. So this is gravel. This is the second layer on top, right? And then they'll put maybe a bigger gravel on top of that. Okay, so different grades of gravel. So this is still gravel, still very small stones, but it's bigger than the layer underneath. So this is a bigger grade of gravel. So there's another layer of gravel, okay? And then what we do, of course, is we put the water in here. We fill up the tank, so the water comes in, it sits here like that. And of course, gravity starts to pull it downwards. So gravity is going to pull it downwards. It's going to flow down through the layers of filtration. It's going to flow down through the layers. And of course, what's going to happen is that the particles will get filtered out. So up here, along the top here, we're going to have the biggest particles, the bigger particles. Okay. And then down here, we're going to have the real fine particles. I'm just going to go to the smallest pen, so the green down here. It's hard to see them because I'm drawing them so finely. But down here, it's the green particles are going to be removed. The fine particles are going to be removed by the sand. And then eventually, the water that comes out on the bottom here, the clean water, should be pretty much sediment-free now. So this stage 3 is known as filtration. So this is the filtration stage. So just to recap again quickly, big picture here. The water is coming to your home. It can't come straight to your home. It comes from the river and the lakes, and it needs to be treated. So the 3 stages so far, we pass it through screens, and then we settle them in a settlement tank. This removes the biggest of the contamination, biggest particles. We then pass it into a second tank, And this, we're trying to get some of the smaller particles to sink to the bottom or to sediment. They require a bit of help. They require a flocculating agent, that is a chemical called alum, that causes the particles to be attracted and stick together, and then they'll sink to the bottom. They'll settle. So particles clump and settle, that's the flocculation stage. That water then goes through a filtration stage where it's passed into a tank with different layers or different grades of materials that will filter out the particles, the remaining particles in the water. So sand is the finest at the bottom, and then above that you've got layers of gravel. The water passes through from the top down, through the gravel, through the big gravel, through the fine gravel, and through the sand, removing smaller and smaller particles as you go. Of course, this stuff here eventually is going to be over-contaminated with particles, and it's going to need to be scooped out and replenished with fresh materials. So the filtration stage is probably the most intensive at the water treatment plant, because it continuously has to be resupplied with new materials. With the tanks here, you can just get in and dig the sediment out of the bottom every now and again. You can clear out the sediment. But with this, you actually have to relayer your filtration materials, because they will get clogged up and they'll get filthy after a while, right? So we're nearly there. So we're just going to write here that these two materials, they need replenishing every now and again. They need replenishment. So, right, we're nearly there. We're nearly ready, but there still are some other concerns with the water, right? So after we take after the filtration stage, this water then can be passed into another tank. So there's a lot of tanks involved, right? So the water is passed in here, fills up the tank. However, it's still not going to be ready to drink yet. We're going to need a few more little processes here. This stage is typically called the adjustment stage. Because the water is still not quite right. One of the things that's not right about the water is that it will contain bacteria. Bacteria are too tiny to be filtered. Bacteria are too tiny to be filtered by the filter. Okay, they're just super tiny. They'll get through even the gaps in the sand, right? So bacteria need to be dealt with. So what we do here is we add a chemical called chlorine. This is the same chemical that's added to swimming pool water for the same reasons, to kill the bacteria in the water, but it's added in obviously much higher concentrations in the swimming pool, because people actually bathe in the swimming pool and people aren't drinking that water. You can't really add too much chlorine to drinking water, because it'll change the taste of the water and it makes it a little bit toxic. So the chlorine will kill bacteria, right? So that's why chlorine is added. So this is known as chlorination. So chlorination of water is in order to kill bacteria. So that's one of the things that happens in adjustment, chlorination. The second thing that might happen in the adjustment stage is that the water gets tested. The water gets tested for pH. Depending on where the water has gone through, different rocks, that kind of stuff, the pH with different minerals can be dissolved in it, and sometimes the pH can be either too high. So for example, if it was greater than 9, it's too alkaline, this water. What scientists will do, or what the water treatment plant will do here typically, is obviously if you want to bring down the pH, you want to add an acid. So the acid they'll add here is sulfuric acid, H2SO4, and they'll be constantly testing to make sure they're not adding too much or too little. They're adjusting it to the right range. So trying to bring it to the pH 7 range, right? If it's too low, if it's less than 4, for example, now the water is too acidic. So to balance this out, they're going to add a base. The base they usually use is called calcium hydroxide, or lime. They add lime, okay, and that'll bring it again up towards the pH 7 range, and that's what they're kind of looking for. So this here is called the pH adjustment stage, where an acid or alkali is added in order to bring it into a suitable pH range. pH adjustment. The final thing that's done, this isn't usually done in every country, but in Ireland, one of the things that's done is a third chemical is added here, and that chemical that's added is called sodium fluoride. Sodium fluoride. This is a chemical that's added to the water, and it's a source of fluoride, or what we call, this is called the fluoridation stage. And the reason why this is added is it's a legal requirement in Ireland, because sodium fluoride is a particularly good chemical at preventing tooth decay. Okay, so this is added in Ireland. It's not added in every country, but many countries do add fluoride to the water, and that prevents tooth decay. So that's the final adjustment that gets made. So fluoridation, and the purpose of that is, again, to prevent tooth decay. Okay, so now we understand, and that's it now. That water then goes to homes. That water is pumped out. Oh, I didn't mean to do that. I want the blue one. Blue marker, please. Okay, that water then is pumped out. Sorry, this OneNote is not doing what it's told. Yeah, this water goes to homes. So now we're at the stage, if we look at the big picture, we're now here. This is where it's flowing now into homes at this stage. Now, what we haven't dealt with is what happens after we use the water in our homes and it has to leave our homes again, right? So what happens once we've used it and it has to go out of our homes? Where does it go now? That's what we're going to do. We're going to do that in the next lesson though, okay? So far, we're up to how does water become potable and gets delivered to our homes. It's known as the water treatment process. So what I'm going to do is I'm going to get you guys to read through the following section here again. This recaps what we've done. I should probably say screening and sedimentation here, because otherwise you might forget the screening process. I don't want you to do that, okay? But it's probably a good idea to make notes on this. This is a really nice exam question if it comes up. If this comes up as a half question, it's really, really nice. But you got to know your stuff. You got to know your details. Things like knowing that alum is the flocculating agent. Things like being able to explain what flocculation is, things like knowing the chemicals that are added to adjust the pH, these things, the little details. If you want the higher level, the H1s, H2s, that's what you have to know, guys, right? The purpose of fluoridation, that kind of stuff, right? All them little details, but having a good outline of everything and the reason why we do the water treatment process. So pause the video, make a couple of notes on that now, please. And then we are going to answer the following questions for me, okay? So these should help us build up our understanding of, okay, I'm just going to do it in two sections. So first, pause the video, do 95 to 102. Okay, now that you've got them done, we've got 103 down to 107. Okay, pausing the video and doing those now. Right, guys, so that's the video on water treatment. A reminder then that the next day, what we're going to look at is what happens to the water after it's finished in our homes and after it leaves our homes. That's a separate process. You can't just dump it back into the river, okay? That would obviously be really harmful because we've put washing powder in there, we've showered in there, we've peed and pooped in there. You can't just pump that water back into the river or the lake, because then what happens to the person who lives down here, right? What happens to the person who lives down here, or what happens to the fish that live in the lake here, right? So you can't just do that. So that's what we're going to look at the next day. That's the big picture again. Right, guys, I'll see you in the next video.